Rachel, who does not have her microphone. Hi, I'm Rachel. I'm a UI engineer at OpenTable, and this is Kara. She's a software engineer at OpenTable. We've spent the last several months with web components, Polymer, and most especially Angular, building a library of user interface components for OpenTable's product, Guest Center. Over the next 20 minutes, with mixed excitement and nostalgia, we'll take a little journey through combining user content with predefined template of a container component, how web component standards add native functionality, techniques for a pre-web component application using Angular 1.3, and the way that we'll work with web components in Angular 2. Since time immemorial, we web developers have employed templates and includes in order to reuse site-wide layouts, like this one here, on different pages without having to rewrite them. Long, long ago, we used server-side includes. Later, we used JavaScript template systems. But the more modern approach to this sort of code reuse is to create a UI component, often linked to a custom tag, which ideally bootstraps all of the markup, scripts, and styles required, and which also acts as a declarative API. This is what we did for the OT site content container component. Why? Well, this is inspired by how native HTML elements work. For example, a native range input brings everything it needs for its appearance and functionality along with it. It also exposes a way to control relevant options, like min and max values. But a component like OT site is a layout scaffold with multiple content containers, so we need more than attribute values. As component users, we need to insert our content, big old blocks of dynamic HTML, into the scaffold that OT site provides. This was a challenge that we faced with OT site, and of course, there are a bunch of ways you can do this, but it turns out they have a lot in common. Such as, first, let's put our component developer hats on and write the HTML that will be built into our OT site container. In this case, that's the head, the menu, and body, the containers in which we want to insert content, plus some static stuff that should be on every page, such as OpenTable's awesome new logo and the footer with copyright. Then we have to mark, in some yet-to-be-determined implementation-specific way, all those pre-designated insertion points. Now, we're going to take off our component developer hats, and we're going to put on our component user hats. We have to add content to OC site by nesting it inside. And since there are multiple insertion points, we're also going to have to label where the content should end up. Next, those two things are going to come together, and there'll be some tactic that each specific implementation will use to match up each insertion point to the left with its relevant content on the right. Finally, after matching everything, we're going to get a result. The combination of component template and user content will get rendered. Web components standards aim to provide this insertion point functionality natively. This harkens back again to how native elements work. When we use the range input on a page, the markup we write is merely what we see on the screen, and we get rich functionality in return. This is what we're used to seeing. How it actually works, though, builds both on the DOM that we already had and already knew, and a DOM that we didn't know we had. When we turn on Show User Agent Shadow DOM in Chrome Developer Tools, we can see a secret DOM. The plain old everyday element in the plain old everyday DOM tree actually has a hidden shadow tree. So from now on, to keep things straight, let's call the DOM that we knew the light DOM. And what exactly is this shadow tree? Well, it's a bit like a document fragment. However, unlike a typical document fragment, the shadow tree is a complete and totally encapsulated DOM, and it actually remains separate throughout its life in many practical ways, including encapsulating script and scoping styles. With web component standards support, we're able to create our own shadow trees. In order to do that, we actually still start in the light DOM with an element to play host to our new shadow tree. To illustrate, we'll use the span in the light DOM with the ID myspan. In order to make myspan a shadow host, we have to create a shadow root on the span. The shadow DOM specification defines a create shadow root method, which does exactly that. So we'll just grab our span and employ the method. That's really all that it takes to give my span a shadow root, and the result is something like this. From this point on, any light DOM descendants of our gracious shadow host won't render. So that sentence that's wrapped in my span is missing now. You may be wondering how that could possibly be useful. Well, now that we have one, we can add elements to the shadow DOM, and those will render. That means that we can implement our OT site container, just as we outlined earlier, starting by appending its template to our shadow root. We could dress this up with more web component goodies, but for now, we'll stick with the bare essentials, and we'll set the template on the shadow roots in our HTML. So, by the way, see those backticks? That's an ECMAScript 6 feature, template strings. When we use those, we don't have to escape quotes in our OT site template. And we can use line breaks. It's just a lot less noisy on our slides, and it's very convenient for inlined HTML. So, now that we've added the OT site template to our shadow DOM, if we also add styles the same way, this is the composite DOM we've actually created. OT site is in the light DOM, and it hosts a shadow root that contains that template. As a result, this is what we get when we use the OT site tag. We get 6 tags, a logo, and styles for the price of 1 tag. But we still need to be able to add our content. So let's deal with these placeholders. When we're implementing with the shadow DOM, we can use the content tag. A content element creates a content insertion point, a place where elements from our light DOM can appear. Content insertion points are how we can fill the containers in our template with dynamic user-defined HTML. But we have multiple insertion points. And somebody thought of that. The content tag has a select attribute. The value of the select attribute is a CSS selector, used to specify which parts of the light DOM can appear at each insertion point. Here, we've defined some attribute selectors. In the header, for example, this will match any light DOM children of OT site that have the head attribute name. So now we'll be component users again. We need to add the attributes we defined in the component to our content as well, in order to label the appropriate destination for each div. We just add, for example, the attribute name head on the div that should display in the header of OT site. Next is the matching step. But since the functionality is native, we don't have to deal with this ourselves. As long as we didn't make any typos, the insertion points defined in the component on the left will be merged with the appropriate labeled user content on the right. Which brings us to the result, and to a very important thing to keep in mind when using the shadow DOM. Things only render as if the light DOM and the shadow DOM are combined. What is actually occurring is something that people are calling content projection. The user's light DOM content is projected like a movie onto the big screen, onto the insertion point, which makes it render in some ways as if it were there. But it isn't. For most purposes, like script execution context, events, and styles, the user stuff is still in the light DOM, and the component stuff is still totally isolated in the shadow DOM, almost as if they're each processed separately before ever rendering together. So, say we had a style in the light DOM that made the text red. What happens? We get red text. Regardless of the rules in the shadow DOM style sheet, how specific the selectors are, because the text does not move. The text is still in the light DOM, and it can still get styles from the light DOM style sheet. It doesn't inherit from the shadow DOM style sheet quite the way that it would if we were actually appending a document fragment. But by the same token, the red rule doesn't affect our text in the shadow DOM, like the copyright. Removing the red, however, shows how content projection gives us exactly what we were looking for, but with the extra added benefits of shadow DOM's encapsulation and style scoping. And that covers the process of implementing the OT site container using web components and native functionality. Now I'll hand over to Kara, who will talk about Angular.
Hi, everyone. So now that we've built the OT site web component, I'll show you how to achieve the same effect with a normal Angular 1.3 directive. So to understand how that works, we're going to build it together from scratch. So I've started us out with a basic directive definition. At this point, it only has a name, OT site. So let's get started by adding a template. We'll use a similar template as we did for our web component with our 3 empty sections and our static logo and footer. The template alone will get us this empty container, but the challenging part is still ahead, finding a way for component users to pass in their content. So how can we do that? In Angular 1.3, we can use a strategy called transclusion. Transclusion in Angular allows component users to pass an HTML template into a directive by inserting it between the directives tags. That user template will then be appended to some part of the directive's internal template. You'll notice that the markup for the component user is similar to the markup that we used for web components. The distinguishing part for Angular, given Angular's concept of scope, is that the user's template maintains a connection to the original scope from which it came. So any Angular bindings the user adds will work as expected. So how do we wire up this transclusion on the directive side? Well, the first thing we have to do is indicate to Angular that we will be transcluding by setting the transclude property to true. This is necessary because during the compilation phase, the default behavior for Angular is to replace anything between the directives tags with the directive's internal template, which normally would make sense. But in this case, it would actually overwrite our user's content. However, when you set transclude to true, the process changes. When Angular begins to compile the OT site directive, it won't add the directive template right away. Instead, it will first save a clone of the user's content. Only then will it empty the directive and add the directive's template. So we still have access to the clone. So we've set transclude to true. How do we actually set the insertion points for our content? Well, if we were creating a web component, this is simply where we'd add content tags, right? Angular 1.3's rough equivalent to a content tag is a core Angular directive called ng-transclude. But ng-transclude won't get us quite there. It's really intended for basic transclusion, so it doesn't have a concept of select the way that web component tags do. Consequently, it will always attach the entire block of user content to its element, which would leave us with something like this. So given that we need the ability to treat different parts of the clone in different ways, we'll have to wire up our own custom transclusion functionality. So instead of ng-transclude, let's set our own version of the select attribute, a transclude ID that will serve as the label for each section, abbreviated here as TID for space. And then from the component user's end, we just need to add the corresponding labels. How about a transclude2 attribute, abbreviated to T2? So now that we have our labels, we have everything that we need to start matching. So let's visualize the process and start writing the code together line by line. So to do this matching, we'll want to go through every element in the clone because we know that the user wants every element to be attached somewhere to the DOM. So for each element, first we need to grab the value of that element's transclude2 attribute. That will give us the ID of our target element. Then we need to find the element in the directives template whose TID property matches that ID. Lastly, we need to append the clone element to its target. And that's it. It's pretty straightforward. So if we look at the consolidated version of the code that we just wrote, line by line, here it is. So aside from some error checking and validation, this is all the processing that we have to do. So we've been assuming access to a clone variable that represents the user's content. So how do we even get that? Well, the answer is something called the transclude function. The transclude function is a special linking function that becomes available as soon as you set transclude to true. It takes a callback function that has access to that clone, and you can do any DOM manipulation or processing you need in that context. So the transclude function actually surfaces in 3 different locations in the directive definition: the compile function, the controller, and the link function. So which one do you use? Well, the first thing to know is that not all transclude functions are the same. The transclude function that's passed to you in compile is actually different than the one passed to you in the controller and link. Unlike the latter two, the correct transclusion scope isn't auto-generated for you or linked for you. So at best, you can only get it to work with broken bindings. For this reason, the compile function's version of transclude is actually deprecated, which leaves us with the latter two. How do we choose and what's the difference? Mostly, it's execution order. So the controller of a parent directive will be instantiated before its child directives are linked. This is why controllers are ideal for directive communication. The parent can define any shared methods or scope properties before the child directives will ever need to use them. But this order isn't great for DOM manipulation. If you try to manipulate the DOM before the child directives are linked, the compiler's linking function might have some trouble finding the children to link them properly. So generally speaking, the best practice for DOM manipulation is to use the link function, also known as the post-link function, because the parent directive's post-link function will run after the child directives have already been found and linked. So we really want to use the link function's version of transclude here. So if we go ahead and add a link function and paste in all the custom processing that we already wrote, that gets us most of the way there. So the last thing we have to do to make this a viable component is to set the appropriate scope. The obvious choice for a reusable component is to use an isolate scope to keep it completely insulated from its environment. But how will this affect the user's template? How can you have a transcluding directive that also has isolate scope? If we take a look at this scope diagram here, we can see how this kind of works together. So on the left here, we have the DOM hierarchy that we've created, color-coded by scope. And then on the right over there, we have the matching scopes organized by encapsulation. So we can already see that there are actually two scopes associated with our OT site directive. We have the directive template scope, represented by the orange OT site tags, and the scope for the user's content, represented by the gray divs. So the directive's template is actually completely isolated from all of the other scopes, as you can see with the box isolated on the bottom. And that's great, because that's what we want. We want it to have no leaks. But the user's content is actually a child of its outer scope, the controller, so that it can inherit any bindings that it might want to use in its template directly from the controller. So this would absolutely work. Which leads us to the final version of our code, which will get us the same output that we got with web components. Okay, so how about Angular 2? Does it make the process we just outlined any easier? The short answer is yes, absolutely. Angular 2 has the concept of component directives, which are built on top of web components. And so component directives combine the best of both worlds, web component standards and the advantages of Angular, bindings, dependency injection, and so on. There are a few differences between Angular 1.3 directives and Angular 2 component directives. First, in Angular 1.3, component authors had to use transclusion to insert custom content. In Angular 2, the concept of transclusion is no longer necessary. Because component directives are built on top of web components, we can simply use the built-in web component functionality, even with multiple insertion points. What this means for our directives template is that we can replace our custom TID attributes with the more powerful content tags that are modified by select attributes. So web components will be doing most of the work for us natively. So all that extra processing, like the transclude function and the transclude flag, aren't necessary to define. In Angular 1.3, another conceptual hurdle is understanding scope. As we saw in this diagram, we had to think about transcluding scopes versus isolate scope and how they interact, and complicated. But Angular 2 provides some sensible defaults depending on what type of directive you're creating, which reduces much of that uncertainty. So if you're writing a component directive, it will have a completely isolated execution context by default. You don't have to set it yourself or even understand the full scope hierarchy if you don't want to. Additionally, if you elect to use content tags to allow user-provided templates, your bindings will still work. So at this point, if we remove all the unnecessary code, you can see that the only configuration we really need is the name and the template itself, which is pretty cool. So the only thing left to do to convert this to a true Angular 2 directive is to update the registration syntax. So in Angular 1.3, to register a directive, we had a somewhat cumbersome directive definition object. We have to call a directive function, to which we pass a factory function that returns an object that contains everything we ever want to associate with this directive. Instead of this one large config, Angular 2 provides a simpler interface for component authors, splitting the definition out into two logical parts, the component class and its metadata annotations. The first half of creating a directive is defining the component class. It controls the component's business logic and can expose a public API for other components. Here we've defined it using ES6 class syntax, but you can achieve the same thing with ES5 using a normal constructor function. So normally there would be methods in here, but as our OT site directive is an inert scaffold, we actually don't need any methods. What we do need is to record those two pieces of metadata, which brings us to the second half of our definition, annotations. Since we're using ES6, which doesn't have a native concept of annotations, we simply set a static property on the class called annotations, and Angular will pick it up. By annotating our OT site class, we can succinctly indicate the class's intent. In this case, that we're building a component directive. And further, we can indicate that this component directive is identified by the OT site tag. You'll notice that we're no longer using a normalized directive name, and we can simply use a CSS selector. Lastly, we can associate our component with a certain template. So at this point, our code is actually fully functional, and the component will work. But we can make the code even cleaner. If we were to convert this to @script, or I guess TypeScript now, we get even more syntactic sugar. We don't have to manually set the annotations property anymore, because that's native. And we can simply annotate using the @shorthand. Lastly, we can move the metadata up to the top of the definition, so you don't have to scroll through all your class code just to see the selector and the associated template. And that's it. That's all you need to do in Angular 2 to implement the container. So you get the same output. So that's it. Thank you.